All right, so we continue solving our task, and let's share my screen and check what we have. We should return the minimal length of subarray whose sum is greater than or equal to target. If there is no such subarray, return 0. So for example, I have 7, then I have numbers 2, 3, 1, and so on. And here, for example, I can check. So we need to return the minimal length of subarray whose sum is greater than or equals to target. So for example, we add 2 plus 3, 5 plus 1. Okay. 2 plus 3 plus 1, it would be 6, and plus 2 would be 8, right? So here it would be 4. Then we can decrease. We can decrease 3. And if we decrease, it would be less, because it's 6, so we need to add 1 more. And we add 1 more, we get again 4. Then we decrease, we have 3. We decrease once again, we have less, then we increase more, and then decrease. Yeah, so I think here it's quite simple. So we just have 2 pointers, and we increase or decrease in case of current sum. So let's check current sum would be 0. Then we have result. And also we need to have another pointer of j. And here we just increment every time with I less than num's length. And here we return result. So what we have here? So here we add to current sum nums I. Then while yeah, I think we can do here. Yeah, we can add to current sum the result, and here while current sum is greater or equal to target, we should start decreasing our j, and we should do like current sum minus nums j plus plus. And here it would be while j is less than I. Less or equal. Here we have our result. So result would be mass minimum between result and I minus j plus 1. Here it would be integer, so the maximum 1 billion. Oh no, here the maximum number is 10 billion, 10,000. Okay. Yeah, I think that's pretty much it what we need. Let's quickly verify our logic with this example. I think it's a good one. So we have 7, and we have 2 pointers. Current sum would be 0. And so yeah, let's start. So first we increase current sum with 2. Then we check. If current sum is, so j is not less, so we even don't go with this one. And here we have a result, but in result we should put only if current sum is greater or equal to target. If it's like this, then we should yeah, check this one. Otherwise it would be result. So current sum is 2, so 2 is not greater or equal to target, so we go next. Then we have 3, so we add 3 would be 5, and 5 is not greater than 7. So we go forward to 1, we add 1, 6, then we go to 2, and we have 8. So now we have 8, and if we have 8, yeah, so I think here we should start this one. Yeah, maybe I don't need this one. Okay. So I update my result when I go here because sum is greater and equal. So current sum is 8. So I'm going here and my I currently on 1, 2, 3. So 3 minus 0 plus 1, it will be 4. 4 elements. So I update my result to 4. Then I going to decrement my current sum by 2. So I decrement it by 2 and it becomes 6. Then I go to the next one. I add 4 to 6, it would be 10. So 10 is greater and I still have 4. And now I decrement 3. It becomes 7. So I calculate and it becomes 3 here. Then I decrement one more time, 1, and it becomes 6. So when it becomes 6, yeah, so when it becomes 6, I go forward and add another 3. So with 3, it becomes 9. And I calculated still 3. Then I move forward and I decrease 2. So here it becomes 7. And yes, so I'm going still here. And 7, it's still my value, and it becomes 2. And I return. So yeah, so it seems that it should work. So let's run. Yeah, I need to log in. So let's quickly log in. And let's run. Yeah, so first it passed, but second tone doesn't pass. So we have 4, 1, 4, 4. So output 2, expected 1. Maybe should be equal. Here Okay, and here we should check if, let's say it's like -1. So if it's -1, then 0, otherwise result. Okay, so 10,001. Submit. Okay, so we're done. Let's check previous submissions. Yeah, so pretty much the same. Pretty much the same we had here as well. Editorial sliding window. And that's it. Yeah, so only one sliding window we have. Let's go to the next one. Find k closest elements. So we are given a sorted integer array, two integers k and x. We return the k closest integers to x in array. The results should be also be sorted in ascending order. So for example, we have 1, 2, 3, 4, 5. We have k4, so we need to find 4 elements that is closer to 3. And is 2 and 4, then 5, 1. So I believe, okay, so here 4, -1, 1, 1, 2, 3. It's interesting, like what if here we return like 2, 3, 4, 5. Would it also work? Return list of 1, 2, 3, and 5. Let's run. Yes, so it doesn't work. Doesn't work. Given sorted integer to integers, return k closest integers to x in array. The results should also be sorted. An integer a is closer to x than an integer b if I minus x is greater than b, or I minus x then by n. Okay. Makes sense. So here it would be 1. Here it will be also 1. So that means that we will take logically this element. So here we actually, if it's sorted array, we can find by binary search the position. If we actually found the position, so it log n, and then we can iterate by k, but k can be n. So actually we can just find by one iteration, just simple iteration, the position. And then from this position, we can start moving two pointers to the right and to the left. to the right and to the left. So let's do it. So first, we should find I. I is less than array length, I++, and here if array I is greater than x, we break. So for example, we have 3, right? So if it's greater or equal, so if it's equal, so for example, we break it's on 0, and here we break on 3. So now we have this pointer. So now we can have left, it will be I minus 1, and right, it would be I plus 1. And also we have k minus 1. And here we should do like this, while k is greater than 0. So first, we can just first add and then sort these arrays. And yeah, so we can just create integer results, array lengths, and yeah, then it would be with n log n. But I believe with n log n it should work. So we have, I know, some j won't be 0. So first we put into result j++. We put array with I and decrement k. Then we have left and right. And we check if we should go to left or we should go to right. So every time we should decrement kaba 1. Then we should do arrays sort array result. And then we should just return results. And here, what we need to do, we should check if left is less than 0, then we just go right. So we put into our result j, we put array left or left right plus plus. Else if right is equal to array length, then we just put result j, we put array left minus minus. Else it means we have actually these points, and now we should decide. But then we should do j minus 1 because we are going, or 7 plus 1. And here we should decide. So array, so first mass absolute, array left minus array I, yes, minus array I, if I need a is closer to x. Yes, if is less than this one, right? We should select array left, but if they are equal, yeah, so when we should select left, so when is less or equal, yeah, so when is less or equal, then we should select left and we should just result j array left minus minus. Else we should do result j right plus plus. Let's run. Yes. So here it should be like list of. Maybe we have such thing. No. New array list. Maybe we have this one. Okay. Array to list Java. Let's check how to do this. Arrays is list. Okay. Okay. Let's try. Integer. Okay, yeah. Looks like quite complex, but let's try. Zero. When we have zero, let's not sort. Let's check. So at the end we add zero. So first we found 3, then 2, 4, then 1. Ah, yeah, so we should have k. Yeah, so now it works. Yeah. So at the end let's use this test case. Okay, 9, x4. So we put 3. And 9 elements. So here we have 9 elements. Left, right, absolute, So we take left and right. So here should be 3. Oh no, so here it's even should be not 3. Let me run. Why it's 9? Let's not sort. So when we add this 9. Yeah, so here first we add 6. Ah, we took 6, but we should took not 6. Yeah. So yeah, so here's the problem. We have 3. Yeah, we should take 3 and not 6. So I think this is a problem here. I think this is a problem here. So what we do, we check. I equal to 0, like I equal to 0, then 0, otherwise I minus 1. Yeah, so now it works. Let's bring sort again. Submit. 1 expected. Okay, so we have 9. X9. Yeah, so here we should check. Yeah, not this one, but we should check the following. We should make like this. So we take array I. So it would be like mass absolute array. Let's do like this. So 0. Otherwise, we should do like this. So mass absolute array I minus 1 minus x and greater than mass absolute array I minus x. And here we should have 2 values. So when, if, so for example, we have 1 minus 9, it would be 8, and 10 minus 9, it would be 1. So here we should select I, otherwise I minus 1. Let's use this test case. Let's run. Let's submit. Mm. 0, 1, K2. Yeah, so if they are equal, as well. Okay. All right, so let's check solutions. I think we didn't solve it, so let's check solutions that we have. Okay, so we take a mid, left and right. Okay, so here we take like 2 pointers at the start and at the end, and then while this is greater than k, we compare value here and value here. If this value is greater than this one, we move low. Okay, yeah, that's totally makes sense. Absolutely brilliant idea. So let's write it down. So we have integer j and then length here, and then while j minus I is greater than k, we do this logic. So if mass apps array j, let's say I minus k is greater than mass apps array j minus k minus 6. So if this value is greater, then yeah, so we have some x, and we can check if this value is greater, then we should move our left. So we should do like I plus plus, else we move j minus minus. And here we have like 2 positions. So what we can do, we can do like system copy, system array copy from 2 indexes. So here we just need to create a result array with k elements. It will result. Here it will be source, and then we need source position, destination position, and length. So destination position 0, source position is I, and length is j minus I. Yes, yes. And then we just return, we return this thing from here. Arrays, let's say int array to list. Let's check how to do it faster. Arrays as list. I think this one. So here we have result. Let's run. Nice one. So here we have output 0, 1, but expected 1, 3. So let's check what the problems we have here. Yes, should be equal, I believe. 0, 1. Okay. Yeah, so I think here maybe we need +1. Now submit. All right, so we're done. It's actually quite simple task. Quite simple task that we done. Yeah, but yeah, we should remember this actually logic, because without having 2 pointers from the end and from the start, it will be quite hard to implement. So let's end for today, and we can mark it as done. And tomorrow we have 2 hard tasks.